Hello students, today we are going to discuss the third numerical of analysis of truss by method of joint. Question is written as, for the loads shown on the truss, find forces in the member of the trusses. Now we need to find the forces in each member of the trusses of the truss shown in the figure. Now this truss is subjected to horizontal forces P on the opposite joint. If we just write the name of the member here, that is A, B, C and D. So at joint C there will be a horizontal force of P magnitude. Similarly at joint B there will be a horizontal force of P magnitude. Now the horizontal and vertical member length will be equals to L meters. Okay. Now, for the determination of forces in each member, we just take the conclusion that will be obtained from the previous questions. Okay. Now, at this joint, due to this P force, this joint tries to move in the leftward direction. Now, to make this joint in the equilibrium position, we need to create a force in the rightward direction. So, we had created a force in the rightward direction like this. Now, this force will create this member to move in the rightward direction. Okay, that is member CD. Okay, now due to this force, the member will try, or the member CD will try to move in the rightward direction. Now to make this member in the equilibrium condition or stable condition, we need to create a equal and opposite force in this direction. Now due to this force of P magnitude, this member CD will be in equilibrium condition. Now due to this D force, or the force which is acting at joint D like this in the outward direction, this force tries to move this joint towards the left direction. Now to make this joint stable or in equilibrium condition, we need to create a force in the rightward direction like this. So we had just considered the equilibrium condition of joint C and joint D, and due to which member CD will be subjected to a tensile force of P nature. Okay. Now at joint D there will be no vertical forces. That's why the vertical component will be equals to 0. Similarly at joint C there will no vertical forces acting at joint C. So the member force in AC will be equals to what? 0. Now at joint D, there will be no inclined member or no inclined component of forces will be present at joint D. So the force in member AD will be equals to what? 0. Now we will just take the equilibrium of joint B. Now if we take the equilibrium of joint B, then there will be a P force which is acting in the rightward direction. Now this rightward P force will tries to move this joint B towards the rightward direction. So we need to create a leftward force of equal magnitude, that is P. Now due to this P force acting in this direction, this P force will try to move the member BA in the leftward direction. Now to make the member AB in the stable condition, we need to create a force in the member AB like this of P magnitude. Okay, now due to these two forces, this member will remain stable or in equilibrium condition. Now because of this P force, this joint A will tries to move in the rightward direction. To make this joint in the equilibrium condition, we need to create here what? We need to create a leftward force of P magnitude. Now due to this leftward force, this joint will become stable, and due to stability of this joint, we had determined all the forces in each member of the truss. Now at joint B there will be no vertical forces acting at joint B, so the forces in the member BD will be equals to what? 0. Similarly at joint A there will be no vertical forces or no component of forces in the vertical direction, so at A there will be 0 force acting. Okay, so the total tension force will be in two members, and there will be three members of 0 force. Okay, so we had just write here as two members are in tension and three members are 0 force member. In this way we had calculated our third numerical. Thank you very much, students.